Water from a 3-meter tall by 30-meter diameter holding tank flows vertically down a 7-meter length of 1 diameter pipe into the bottom of a massive gold-plated jacuzzi through a 10-inch diameter horizontal nozzle. The water depth in the jacuzzi is kept at 1 meter by pumping water back into the tank. The energy-conscious king wants to know how much power the 100% efficient pump requires. If the pump is perfectly insulated and transfers no heat to the water, is a chiller necessary to keep the water at the same temperature? From the given information in the question, we are able to create a diagram that looks like this. With a 3-meter deep holding tank, 30-meter wide, a 7-meter length horizontal drop with a 1-meter width, shooting over in a horizontal pipe with a 10-inch width into a pool that is kept at 1 meter by pumping water through an 100% efficient pump back into the holding tank. Within the question, we have 2 parts. Question 1 of how much power the 100% efficient pump requires, and question 2, is a chiller necessary to keep the water at the same temperature? Let's visit question 1. How much power does the pump require? We know that power equals work over time, and we know that work is force multiplied by distance. We can begin to create our equation for power, saying that power is equal to work over time, and we can substitute in for work force multiplied by distance over time. We know that velocity equals distance divided by time, so we can substitute velocity in for our distance over time. We also know that force is equal to pressure multiplied by area, so we can substitute pressure and area in for our force. We know that pressure is equal to density multiplied by gravity multiplied by height, so we can substitute rho GH for pressure and come up with this new equation. We know that height, area, and velocity is equal to heat multiplied by H net, so we can come up with our final equation here. Substituting in our numerical values, we come up with this lengthy equation, which after plugging into a calculator will produce this answer. So we now know that the power the pump requires is 69.5914 kilowatts. Is a chiller necessary? A chiller would not be necessary given that the pump operates at 100% and is perfectly insulated. Because of this, no heat will be transferred to the water as it passes through the pump.